This is the final demonstration for the HERIPORT project. As seen in the diagram, the HERIPORT system consists of 3 layers which will be spoken about in the demo. The data provider interface is a software component that consists of 2 Python scripts that map data provider XML metadata records to unqualified Dublin core and expose the metadata using the OAI-PMH. When a service provider sends an OAI-PMH request to a data provider, the request is handled by methods located in the Python script. These methods include reading the original metadata and converting it to the DC format in the DC converter script. The data provider interface script then requests the DC converted metadata and returns the appropriate OAI-PMH response to the service provider, who can then store the metadata in their harvested metadata collection. An example of a DC converter application is the FHYA DC converter.py. The script is designed to convert XML metadata records read in from a directory path and output the converted DC XML metadata records so that they can be accessed by the FHYA interface. Here is the output of the converter. To interface with the FHYA data provider interface, enter the server URL concatenated with the name of the data provider interface and a valid OAI-PMH request. The data provider interface is able to receive OAI-PMH requests and output OAI-PMH responses based on the DC metadata records generated by the FHYA DC converter. Here is the get record response, identify response, list identifiers response, list metadata formats response, list records response, list sets response.
From our last demo, we were able to harvest all records, convert them and index them into Apache Solr. In this demo, we fully integrated the system, so we're now able to harvest from our data provider interfaces component and index into Apache Solr, which is used by the web portal. On the left, you can see the sequence diagram that is used for the bash script process. We've also added a harvest to date bash script, which uses selective harvesting, so only records that are newly created or modified are added. On the right hand side, you can see the outputs of these processes. The harvester uses a resumption token to make use of incremental batch harvesting. Once records are harvested, feedback is shown on the terminal, and once they're converted, it's also shown. And lastly, when they're indexed, it is shown on the terminal.
Finally, the web portal component has been implemented on a UCT server and uses Apache Solr technology for indexing, searching, and browsing services. As seen in the diagram, the user sends a query to the web portal through a web browser interface. The services are then accessed through the web server, which then sends an Apache Solr standard query to the Apache Solr server. The Apache Solr server processes the query and returns unformatted output to the web server. The web server then returns the formatted user output on the web browser for the user to see. It consists of web pages for the home, browsing, search, and about page. The home page includes a carousel that displays the latest 15 resources harvested to the database. On the browse page, the user is able to browse for resources by title, archive subject, and by year, whereby all the resources in the collection are returned and sorted by the chosen field. The user is able to navigate the records using the previous and next buttons. The user clicks on the title of a record to view all its metadata and is able to click on the identifier link to be redirected to the original source in a new tab. On the search page, the search feature searches for items in the database that matches a user's keyword and is case insensitive. It checks if the keyword matches any of the DC fields of all the records. I will demonstrate its functionality with the keyword moon and the keyword FHYA. As with browse, the user is also able to click on a title of a record to view all its metadata and to click on the identifier link to be redirected to the original source. The About page provides the user with context and information about our project and the team.
In conclusion, we have implemented the first national heritage metadata aggregator with 3 separable and reusable components that could contribute significantly to the research community.